Hey there. So it is a snow day today for some of you who can't make it. So what we'll do is you can watch this video in order to get hints and tricks on how to do number 4 in your assignment. Make it a little easier for you to hand that in tomorrow. A couple things that we need to know. These will relate to the unit circle and how we draw right-hand triangles inside the unit circle with specific angles. But if you would like to know more about how we actually make these, please stop and ask either myself or Mr. McGilvery over the next couple days. So what we have at our toolbox here in Trig are these two things called special triangles. And with these, you can label them either with radian measures, so pi over 3. Again, that's just 60 degrees, so I'll do the degree one below here, just so that way you can visualize what that is. But we know the values here, and we know that the value of this opposite of pi over 3 is root 3. And we know that the opposite of the pi over 6 is 1, and we know that the value of the hypotenuse is 2. So again, labeling the one with just the angles down here as well. And we also have a second special triangle that deals with pi over 4, or values that are multiples of 45 degrees. So 45 degrees can be found down here and here. And this one has values of root 2, 1, and 1, and the same thing up for the radian measure one. So these two are really the same thing, just with different radians versus angles. And this one and the one below is also the same thing. So you'll flip back and forth between using the radian special triangle and the degree special triangle as you go through these. But like I said, as we get deeper into the unit, there'll be less and less degrees and more radians. So how do we actually do a question like this, right? So I say that I want to find the sine of pi over 3. First thing you want to do is remember that our unit circle can be labeled with cast, right? So cos is positive, all of them are positive here. Sine is only positive in this quadrant, and tan is only positive in this quadrant down here. So you must ask yourself, where is pi over 3 located on our unit circle? And here it's located between 0 and pi over 2. So it's somewhere inside this quadrant. Okay, so if that's the case, that all of these are positive, then the sine of pi over 3 must equal something that is a positive number. That's your first step, putting it on the unit circle and figuring out what it is, either positive or negative, and that's your first little bit you have to do. Then you have to consult your your special triangle. So it's well labeled here: pi over 3, pi over 6, root 3, 1, and 2. Now, if we remember SOHCAHTOA, which hopefully all of us do, we did very well on that last little assessment that we did, sine is equal to the opposite over the hypotenuse. So here we're dealing with pi over 3, so the opposite of pi over 3 is root 3, and the hypotenuse is 2. So that means that sine pi over 3 is equal to root 3 over 2 positive. That is all you need to do here. Okay, so when we say, do this on your assignment without a calculator, you don't need to draw out the unit circle each time and your special triangles. It's fine if you just say sine pi over 3 is equal to plus root 3 over 2. That would be fine with us, right? So there's not a whole lot of work involved with showing these things. We just need to get a lot of practice doing them. So I'll go through a couple more. Let's say now we're dealing with cos of 210 degrees. Now, remember, we're talking about cast, so we want to figure out where that 210 degrees is. If it's 0, 90, 180, and 270 are my labels. Well, I know that I'm having my angle, it starts here and it goes all the way through 90 degrees, through 180 degrees, and into some measure of 210 through here. So I know that cos in the t quadrant is going to be negative. So cos of 210 degrees is equal to some negative value. Here we go, and we'll use the degree labeled special triangle. So we'll say that root 3, 1, and 2 as well. Now, you must be confused, or you might be confused, sorry. What do we do with this 210? You have to decide what it is a multiple of. Is 210 a multiple of 60? So can 210 be divided by 60? No, right? It can't. It's not going to be something that is a reference angle for us. So we have to reduce all of these down into something that is a reference angle that we see. So here I can't divide 210 by 6, but I certainly can divide it by 30s. Okay, so if I divide my 210 by 30, that would equal 7. So it is divisible by 30, so that means I will use my 30-degree angle as my reference. So that means my cos, remember cos is CATOA, right? C-A-H. So the adjacent here is going to be my root 3. And my hypotenuse is 2. So cos of 210 will equal negative root 3 over 2. Remember, this is probably the trickiest bit where you have to decide what 210 is divisible by in order to get a reference angle that you like. So here I divided it by 30 and it worked. I couldn't divide it by 60 because it wouldn't have given me something like a whole number there. So here on your assignment you'd be able to say cos of 210 is equal to a negative 3 over 2. I have 2 more examples. If you understand it completely now, you can run away and do the assignment. If you want to stick around and watch the 45-degree multiples, you can stick around for that too. So here we have our pi over 4 special triangle. And hold on a sec, we'll label this root 2, 1, and 1. And we have to figure out where 5 pi over 4 exists on our unit circle. So 0, we have pi over 2, and pi, and 3 pi over 2. You look at this and you might say, well, 5 pi over 4, I don't really know where that is. But I do know where 4 pi over 4 is. 4 pi over 4 is the same thing as saying just regular old pi, because the 4's will cancel. So we know that we at least make our angle all the way to the 180-degree line or to the pi line that exists right here. If we go a little bit extra, we're going to go an extra pi over 4 into this quadrant here. Another way to remember this too, if you're thinking of 3 pi over 2, multiply both the top and bottom by 2, so you get 6 pi over 4. 5 pi over 4 isn't quite 6 pi over 4, so this angle is going to live inside of here. Okay, so that means that we're in the tan quadrant. Remember cast? I didn't label it this time, but we should get in the habit. And tan is going to be positive. Tan's the only thing that's positive there. So tan of 5 pi over 4 is going to equal some positive number. Now, tan, it's pretty easy. You can choose either one, the top reference angle of pi over 4 or the bottom pi over 4, because they are the same. It is an isosceles triangle here. Tan is just the TOA part of SOHCAHTOA. It's the opposite over the adjacent. So you say the opposite of this angle here is 1, and the adjacent is also going to be 1. So the opposite is 1, the adjacent is 1. That means that tan of 5 pi over 4 is just equal to a positive 1 in this case here. Moving on to our last and final example, the cos of 300. So this one might be a little ambiguous when we're talking about 60-degree angles and 30-degree angles. And it's good to kind of wrap your head around this little bit. So this is an exception, not necessarily an exception, but an extra small detail that we should be able to pay attention to. So if I have my labeled unit circle here, 0, 90 degrees, 180 degrees, and 270, and 360. I should be able to place 300 pretty quickly. We're used to seeing numbers like this, so I can say it's all the way past 270, 30 degrees inside of this quadrant here. So that means that cos, C is down here, cos is going to be positive. So cos of 300 is going to equal some positive number. Here is where we might get a little bit confused with 300. Because 300 both can have the reference angle of either 30 or 60 as a multiple. And so in this case, if I do cos divided, or 300 divided by 10, that'll give me an angle of 30 degrees. Or if I do 300 divided by 5, it'll give me 60 degrees. When we're doing this, and you have an option that is divisible by both, we choose the larger angle. So we choose the 60-degree angle in this case here. So we're going to cancel this one out. And we'll say that this is the 60-degree angle is what we're interested in. So we go to our reference, or our special triangle, and we say, well, what is the adjacent to this 60 degrees is 1, and the hypotenuse here is going to be 2. So the cos of 300 is equal to plus 1/2. And that's it. So hopefully, those were 4 examples that should be able to get you started on the question number 4 on your assignment. If not, please email me, talk to Mr. McGilvery at school. I won't be there today because of the snowstorm. So take this, run with it, and try to apply it the best you can with question number 4 on your assignment. Aside from that, please have a fantastic day.